Ever wonder how your weather app knows the temperature, providing you with real-time updates on whether you need an umbrella or sunglasses? It's a seamless experience, but have you ever stopped to consider what's happening behind the scenes to bring you that information so quickly and accurately? Or how travel sites show flights from hundreds of airlines comparing prices and schedules in the blink of an eye? These platforms aggregate vast amounts of data, presenting it in a user-friendly format. But how do they access all that information from so many different sources? The answer is APIs, Application Programming Interfaces. They are the unsung heroes of the digital world, quietly facilitating the exchange of information that powers so many of the applications and services we rely on every day. Think of an API as a restaurant waiter, a helpful intermediary that takes your order and relays it to the kitchen. You, the client, order from the menu, specifying exactly what you want. The waiter, API, delivers your request to the kitchen server, translating your order into a language the kitchen staff can understand, and brings your food, data, back, presenting it to you in a way that's easy to consume. APIs let different software programs talk to each other, enabling them to share information and functionality in a structured, predictable way, ensuring that the communication is reliable and efficient. This standardization is key to the smooth operation of countless digital services. Without APIs, every app would have to build everything from scratch, a monumental task that would require developers to reinvent the wheel every time they wanted to access external data or services. Impractical and inefficient, leading to slower development times, higher costs, and ultimately, fewer innovative applications. APIs are the invisible threads connecting our devices and services, creating a seamless web of interconnected experiences, making things like logging in with Google, using your existing credentials to access other applications, a breeze, or syncing smart home devices possible, allowing you to control your lights, thermostat, and other appliances from a single app. Developers love APIs because they save time, freeing them from the burden of building complex integrations from the ground up, and let them focus on unique features, not reinventing the wheel, allowing them to create more innovative and compelling applications. An API is a set of rules and tools for software to communicate, a well-defined interface that specifies how different components should interact. Defining requests, outlining the specific information that can be requested and how those requests should be structured. Data formats, specifying the way data is exchanged between systems, ensuring compatibility and seamless integration. And conventions. It's a contract, an agreement between different software systems on how they will interact with each other. A shared language for teamwork between programs, enabling them to collaborate and exchange information effectively. As the internet grew, we needed new ways for programs to communicate over the web, to share data and functionality across different platforms and devices, leading to the creation of different types of web APIs, each with its own strengths and weaknesses, designed to address specific communication needs in the ever-evolving digital landscape. Before we continue, if you are enjoying this video, feel free to like, subscribe, and hit the notification bell to receive future updates. In the late 1990s, businesses faced a challenge. Their diverse computer systems needed to communicate over the web. Enter SOAP, Simple Object Access Protocol, a universal, secure way for applications to exchange structured information. SOAP is like sending a certified letter, strict, reliable, and secure. It uses XML, a readable data format, to solve cross-platform communication. SOAP includes built-in rules for security, error handling, and complex operations. Perfect for big businesses. It's a full-service shipping company for data, with tracking and delivery confirmation. For banks, governments, and major corporations, SOAP's reliability and security were essential. SOAP became the heavyweight champion for enterprise web services. It was robust, powerful, and got the job done. But its complexity would soon spark a search for something simpler. Using a SOAP API is like baking a cake from a master chef's recipe. Every step is detailed and must be followed exactly. The recipe book is a WSDL file, a long, complex XML document describing every function input and output. Developers often need special tools just to generate code from the WSDL. SOAP messages are large and wrapped in a strict XML envelope with headers for security and a body for data. Even simple requests become verbose and bandwidth-heavy. This strictness made SOAP reliable for complex business needs, but slow and cumbersome for simple tasks. For many developers, SOAP felt like using a sledgehammer to crack a nut. The steep learning curve and heavy structure slowed development. Naturally, people began to ask, isn't there an easier way? while SOAP, with its intricate specifications, had become a dominant force in enterprise web services, powering countless business applications and data exchanges. Roy Thomas Fielding, a prominent figure in computer science and a key contributor to web architecture, introduced a fundamentally different idea: REST, representational state transfer. His dissertation laid the groundwork for a new architectural style that would challenge the complexities of SOAP. REST isn't a strict protocol in the traditional sense with rigid rules and predefined message formats. Instead, it's a set of guiding principles and constraints, inspired by the very architecture of how the web itself works, emphasizing simplicity and scalability. It mirrors the web's inherent ability to connect diverse systems seamlessly. At its core, it treats everything as a resource, something identifiable and addressable like a user profile, a blog post, or even a specific image, each accessible through a unique URL, much like web pages are. REST leverages the power of standard HTTP methods, using GET to retrieve information or data, POST to create new resources or submit data, PUT or patch to update existing resources, allowing for full or partial modifications, and delete to remove resources entirely. There are no special envelopes or complex XML files required, just simple, intuitive interactions using the existing web infrastructure. REST fundamentally shifted the focus away from rigid, predefined procedures to a more flexible approach centered around accessing and manipulating data. It cleverly leveraged the web's already established infrastructure, which in turn made APIs significantly lighter, more manageable, and ultimately, easier for developers to use and integrate. The inherent simplicity of REST was a breath of fresh air, offering a welcome alternative to the complexities of SOAP for developers. This simplicity enabled faster, more agile web development cycles, allowing teams to iterate quickly and respond to changing requirements with greater ease. And as the web continued to evolve at an ever-increasing pace, REST's lightweight and adaptable approach became increasingly attractive to a growing number of developers and organizations. A new era of APIs, characterized by simplicity, scalability, and ease of use, was about to begin, promising a significant transformation in how applications interacted with each other. REST didn't catch on overnight, but as social media and web startups exploded, demand for simple, fast APIs soared. REST was perfect. Developers could understand it just by looking at URLs and responses. No complex files or tools needed. Testing a REST API was as easy as typing a URL in your browser. This accessibility fueled a wave of innovation and mashups. REST's flexibility with data formats, especially lightweight human-readable JSON, JavaScript object notation, made it ideal for web and mobile apps. JSON meant smaller, faster messages compared to SOAP's XML. The shift from SOAP to REST was a turning point, making API development faster and more accessible. REST empowered a new generation of developers to build and connect services easily. It democratized access to data and services. REST helped shape the interactive, connected web we know today. SOAP and REST are two major approaches for building web APIs, each with its own philosophy. SOAP is a strict protocol, formal, secure, and comprehensive, but complex and rigid. REST is an architectural style, flexible, lightweight, and intuitive, using standard web tools. SOAP requires verbose XML, envelopes, and WSDL files. REST uses simple HTTP verbs and often JSON, making development faster and easier. Think of SOAP as an all-inclusive tour, everything planned, reliable, but inflexible. REST is like backpacking with a map. Freedom, agility, and simplicity both get you to your destination, but the experience is very different. The right choice depends on your project's needs. Understanding these differences is key to picking the right tool. Alright, let's dive into the technical details. We're going to get down to the nitty-gritty differences between REST and SOAP, exploring how they handle communication, data formatting, and overall architecture. Understanding these distinctions is crucial for making informed decisions about which protocol best suits your specific needs. REST leverages the full power of HTTP as it was originally intended. It makes use of HTTP methods: GET for retrieving data, POST for creating new resources, PUT for updating existing ones, and DELETE for removing them. Each method has a specific purpose, contributing to a clear and organized API design. These methods are used to interact with resources which are identified by URLs. Each URL represents a unique resource, allowing clients to easily access and manipulate data through standard web protocols. This makes RESTful APIs intuitive and easy to integrate with web applications. SOAP, on the other hand, offers more flexibility in terms of transport protocols. It isn't limited to HTTP and can also operate over protocols like SMTP or TCP. However, when SOAP is used over HTTP, it typically only utilizes the POST method. This means that all actions, regardless of whether they are retrieving, creating, updating, or deleting data, are sent as POST requests. This approach essentially hides the intended action within the XML payload of the POST request, making it less transparent than REST. REST's approach is more natural and aligned with the way the web works. It fits seamlessly with the existing web infrastructure, making it easier to build and integrate web services. In contrast, SOAP essentially tunnels its own protocol through HTTP, treating HTTP as a mere transport mechanism. It uses HTTP simply for transporting messages rather than leveraging its architectural principles. SOAP is intrinsically tied to XML. Every message is encapsulated within a SOAP envelope, which is an XML document that defines the structure of the message. This envelope adds overhead, making SOAP messages generally larger and more complex than their REST counterparts. REST, on the other hand, is format agnostic. While JSON has become incredibly popular due to its simplicity and ease of use, REST allows for the use of various formats, including XML, HTML, or even plain text, depending on the needs of the application. This flexibility is a significant advantage for REST, as it allows developers to choose the most appropriate format for their data. REST is inherently stateless. This means that each request from a client to a server must contain all the information needed to understand and process the request. No session information is stored on the server between requests, making systems simpler to design and easier to scale horizontally. SOAP, on the other hand, can be stateful, allowing the server to maintain session information between requests. This can be useful for certain applications that require complex, multi-step processes where maintaining state is essential. Furthermore, SOAP has built-in standards like WS Security, which provide robust security features for enterprise-level applications. REST's inherent simplicity and scalability make it an ideal choice for the vast majority of web applications, where performance and ease of development are paramount. However, SOAP's structured approach is often better for complex, highly secure enterprise environments where stringent security and reliability are critical requirements. REST is everywhere in the public web, powering mobile apps, social media, and dynamic websites. When you check Twitter, get directions, or see weather data, you're using REST APIs. REST's lightweight nature and JSON format are perfect for fast, efficient apps. The API economy companies exposing data for others to build on is built on REST. But SOAP isn't gone. It's still vital in banking, finance, and large enterprises needing high security and reliability. SOAP's formal contracts and built-in security make it ideal for sensitive, mission-critical operations. You may not see SOAP, but it's working behind the scenes for secure transactions. Both styles have their place in today's digital world. As a developer, choosing SOAP or REST depends on your project's needs. For enterprise systems needing high security, reliability, or integration with legacy tech, SOAP is strong. For most modern web and mobile apps, REST's speed, simplicity, and flexibility are hard to beat. REST is ideal for public APIs and rapid development. Technology keeps evolving. GraphQL and gRPC are rising too. Stay curious, understand the why behind each technology, and choose wisely. The best developers know the history, strengths, and trade-offs. So what will you build next? Thank you for watching. If you enjoyed this video, feel free to like, subscribe, and hit the notification bell to receive future updates.